All right, we're back with part two. You might want to pause it. I took the time while the thing was compressing to write in the difference between expressions, equations, and functions, and I'll talk about this stuff fairly quickly because we don't spend a lot of time on it, but we do have to think, depending on what we're given, that will determine what we're going to do. So if we're given an expression, what are some stuff that we can do? We can simplify the expression, we can factor and expand the expression, we can substitute into the expression and evaluate. Whereas if it was an equation we were given, we're going to solve it. That's about all we can do with equations, is solve them and maybe check that our solution is correct. Whereas if we had a function, the big thing is that we want to graph functions, right? And that's where we're getting going in this first part of polynomial study of polynomials. We want to graph polynomial functions. But we can also find the max and minimum. We can find the intercepts. We could talk about things like the rate of change, whether it's increasing or decreasing. We've done that a little bit this year. We see some examples: an expression and an equation, no y value in the equation, and a function. And we can see that they're related, right? The expression is just the left side of this equation. It's the right side of this function. There's obviously a relationship between the expression, the equation, and the function. That's why they're so easy to mix up. And then we had a couple more examples, a quadratic example and an exponential example. As soon as we get the y equals involved there, that makes it into a function, and we're going to graph it, right? In general, a polynomial function has the form, and I'm about to write down something that's going to look pretty confusing, but it shouldn't be. The general form for a degree 1 polynomial would be this, right? Sometimes we call it mx plus b, but we think of it as ax plus b, where a is the leading coefficient, right? That's the leading coefficient. It's the coefficient of the highest degree term, and it's 1 since it's linear. And a quadratic one, well, we've seen, or should remember that it's this. And over here we remember that, well, an exponential example, well, we just don't know. But if we had a cubic, which is a degree 3, we'll talk about cubics a lot, well, it'll be this. The thing is, what's this expression? Oops, x squared. Let me fix that up. A cubic has degree 3, and then it just goes down from there. X, and then plus d is the constant term. In general, I don't know what degree this is in all of the terms. Someone was at the door. The dog is now calm. Cubic function. We see still the leading coefficient is a, but if we don't know how many terms we have, say we have n terms, well, how many letters are we going to need? Well, that's why the general form looks a bit strange. We call it, the leading coefficient is a sub n, and then the exponent on x is x to the exponent n, degree x, like I said. And then it starts going down, right? Well, the next a, I can't call this b because I don't know how many letters I need, so I'm going to call it a n minus 1, and that's the exponent x n minus 1, and so on. Right? And well, how do I know when to stop? I don't know to stop. That's why I put dot 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 in there. And then how do I finish? Well, it's going to finish at the constant term, but what comes before the constant term? Well, I got a2 x to the exponent 2. I got a1 x to the exponent 1, but we usually don't write the x to the exponent 1. And then a to the exponent 0. That's the general form. Now, whenever we're doing stuff, these will all have numbers in here. They'll all have numbers in there. Maybe time for an example. Fill in the chart. Use technology to sketch the functions you don't recognize. So this function, highest degree, well, it's 2. The leading coefficient is the number that goes with the degree, the highest degree term. It's just 1. And this is just a good old parabola. I'm just going to draw it real quick. Nothing special, just a good old parabola. This one, notice that this term has degree 1, degree 2, degree 0, but it's the highest degree of all. This is degree 2. The leading coefficient is the number that's in front of the x squared in this case. And the sketch, well, what's the sketch look like? I'll do these later. I'll go to my graphing calculator later. The degree of this one, well, this has degree 0, degree 3, degree 4, but altogether it's the highest degree of the single term. It's degree 4. The leading coefficient is the number that's in front of that x with the highest degree. It's just 1. And now what do the functions look like? Here's my graphing calculator. I think I've already got these graphed. I can't remember whether I did this or not. Yeah, there they are. My first graph was the decimal 5x squared. It was just a parabola. I think we could have guessed that one. And the second one, x to the exponent 4, we've got no idea. So I'm going to actually make one of these thick so I can tell which is which. Okay, so the thin one is going to be the parabola. There's the thin one, that's the parabola, that's no problem. And the degree 4 one is called a quartic. The quartic function is that weird sort of bent W thing. So let me graph those. Parabola was no problem. Quadratic parabola. This one kind of looked like, what did it look like? Down like this and a little bit of a wobble and then went back up. This is a quartic. And quartic is degree 4. Cubic is degree 3. Quadratic, degree 2. Degree 5, quintic. But we don't use quintic very often. I think we get as high as degree 4 in our course, and that's it. How are these functions alike? Well, they kind of all have this kind of U shape. And how would I describe that U shape? You know, it's not a U shape. This one looks more like a W almost. But I like to think about it as starts and ends. So this one starts, all of them start high on the left and ends high on the right. And I can describe that. That's what we call the end behavior of the function. All of these start upper left and end upper right. We could think of it as starting in quadrant 2 and ending in quadrant 1. We could think of it that way. And then notice in the homework, folks, there's a lot here that you can do without writing down. In your head or with a partner. So you go through that very quickly, and then there's a few that you can do written. Okay? Welcome to polynomial functions.